Hello students, welcome back. Today we will continue with exercise 2.1. In our last video lecture we have started with chapter number 2. We have studied the types of relation like reflexive, symmetry, transitive, equivalence. Then we have solved question number 1 of exercise 2.1. Today we will start with question number 2. So see question number 2. So that the relation R in the set R of real numbers defined as R is equal to ordered pair AB where A is less than equal to B square. Okay. So now we have studied in last video that if you want to prove it reflexive, then prove it theoretically, or else if you want to prove it not reflexive, then you can find out any such example, right? See here it is given that the relation must satisfy A less than equal to B square. Now if we can get any single example like AA does not belongs to R, then it will not be equal to reflexive. Clear? So now let's start. Now see, if we take 1 1, then 1 will be always less than equal to 1 square, right? It will be equal to 1. So it will satisfy, right? Similarly, for negative number also, if I take minus 1, the minus 1 less than equal to minus 1 square, it will be always positive minus 1 square. Okay, so if I take any number between 0 and 1, let's take for A equal to 0.1, right? Is 0.1 less than equal to 0.1 square? No, because 0.1 square will be equal to 0.01. So 0.1 will be greater than, right? So what does that imply? This implies that 0.1, sorry, it's and 0, the ordered pair 0.1 and 0.1 does not belong to R because this is not satisfying this A is less than equal to B square. So what does this imply? This implies that it is not reflexive. Okay. Now for symmetry. See, we also have to prove that it is not a symmetric relation. So again, we need to find out any such example like AB belongs to R but BA does not belongs to R. Then it will be symmetric. Okay. So now see, let's take any example like 0.1 and 1. Okay, 0.1 and 1. Now see here I can see that 0.1 is less than equal to 1 square, so this belongs to R. Why? Because 0.1 is less than equal to 1 square, right? But if I want to check 0.1, then 1 is less than equal to 0.1 square. No, so this is false, right? As this is false, this means that 1, the ordered pair 1 and 0.1 does not belongs to R. See, 0.1 and 1 belongs to R, but 1 and 0.1 does not belongs to R. So what does this imply? This implies that it is not transitive. Clear? Sorry, it is not symmetric. Let me erase this. It is not symmetric. Clear? Now for transitive. For transitive, we have to take two examples like AB belongs to R, BC belongs to R. and that must implies AC belongs to R, then only it will be transitive, right? So we have to find out example in which AB belongs to R, BC belongs to R, but AC does not belongs to R. So if we take any example like phi 3, okay, is phi less than equal to 3 square? Yes, because phi is less than equal to 9. Therefore, phi 3 belongs to R. And now with 3, I can take 2. 3 is less than equal to 2 square, right? Because 3 is less than equal to 4. So 3, 2 belongs to R. But what about phi 2? If it belongs to R, then it will be transitive, right? So is phi less than equal to 2 square? Phi is less than equal to 4? No. So this is false, right? So as phi is not less than equal to 2 square, this does not belongs to. See, what you can see, phi 3 belongs to R and 3 2 belongs to R. But phi 2 does not belongs to R. That means it is not transitive. Okay. So hence we have proved that it is not reflexive, not symmetric, and not transitive. Clear? So note down question number 2. Now let's move to the next question, that is question number 3. Question number 3. Check whether the relations are defined in the set 1, 2, 3, 4, 5, 6 as R equal to AB, where B is equal to A plus 1 is reflexive, symmetric, or transitive. Right? See now, if I take this as X, which value I can take? 1, 2, 3, 4, 5, 6. Clear? Then this, sorry, here let's take A and B equal to A plus 1. Clear? So 1 plus 1, 2, 3, 4, 5, 6, 7. So what is our relation? Our relation will be equal to 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7. Do I have 7 here? No, so I cannot take this one. Clear? So this is our relation. Clear? Now, see, now let's start with the first one, reflexive. 1 is there here, right? You can see here 1. So can you see 1, 1? No, 1, 1 does not belong to R. Right? See, for reflexive, it's for every element. Means 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Every must be belonging to R. But here, see, we have found that 1, 1 does not belong, even 2, 2, 3, 3. But 1 is enough. That means it is not reflexive. Clear? Now, for symmetric, let's say 1, 2 belongs to R, right? But do 2, 1 belongs to R? Can you see here 2, 1? No, 2, 1 does not belongs to R. Therefore, it is not symmetric. Okay, now let's take for transitive. Here I can say 1, 2 belongs to R. Okay, 2, 3 belongs to R. Okay, but is 1, 3 belonging to R? Can I see any ordered pair like 1, 3? No, 1, 3 does not belongs to R. That implies it is not transitive. Okay. So our given relation is neither reflexive nor symmetric nor transitive. Here, so note down question number third. Okay, so now let's move to question number four. Question number four. So that the relation R in R. So relation is again from R to R. Defined as R equal to AB, A is less than equal to B. Is reflexive and transitive but not symmetric. Okay, so first we'll start with reflexive. Now see we have to prove reflexive. So I will not take any example, right? So now for any A belonging to R, I can write it down. A is always less than equal to A. See, A is not less than A, but A is equal to A. Any number will be equal to that number itself. So it is satisfying this relation. So what does this implies? A belongs to R. So for every A belonging to R, A belongs to R. So this implies it is reflex. Okay. Now next is symmetric. Now for symmetric we have to take let A, B belongs to R. Remember, for symmetric, we have to assume any relation that any ordered pair that belongs to the relation. So now, as it is belonging to the relation, that means it will follow this A less than equal to B. So A less than equal to B. Now, if I take A as less than equal to B, clear? So this implies that B less than equal to A is false, right? Say, if I'm taking A equal to B, then it will be B equal to A. But in every case, it will be not like if A is less than equal to B, then B is less than equal to A. If A is less than B, that means definitely B is not going to be less than A, right? So this implies that it is not symmetric. Okay. Now for transitive, let AB belongs to R and BC belongs to R, right? I have to assume this. Now, as this both belongs to the relationship, it will follow this. So that means A is less than equal to B and B is less than equal to C. Now, see, when you will join this, A less than equal to B, which is less than equal to C, then definitely that means A is less than equal to C. Now, as it is following this, that means AC belongs to relation, therefore, it is transitive. Clear? So, it is reflexive, not symmetric, and transitive. Here, the relation is reflexive and transitive, but not symmetric. So, note down question number 4. Okay, now let's begin with the next question. That is question number 5. Question number 5. Check whether the relation R in R defined by R equal to AB. Here the relation is A is less than BQ. Is reflexive, symmetric, or transitive. Now, see, here we have to check. Okay, in the previous question it was to prove whether it is reflexive, symmetric or transitive. So you already knew it, your answer, but now here you have to check. So it can be reflexive, it cannot be reflexive. So if you want to prove that it is not reflexive, or if you want to show that it is not reflexive, then just find out any one example that does not satisfy this. Okay, if you are able to do it, that means it is not reflexive. Okay, or else you have to prove it theoretically that it is reflexive. So first, for reflexive, if I take any number, let's take negative number -2, right? -2, okay, less than equal to -2 cube, right? Because -2 cube is -8. So this is not true. This is false, right? This is a false statement. -2 is not less than equal to -2 cube. In fact, it is greater. So what does that imply? -2 -2 does not belongs to R. Therefore, the given relation is not reflexive. For symmetric, let's take example as 1 5. 1 is less than equal to 5 cube. Yes. So that means this belongs to the relation R. But 5 1, okay, is 5 less than equal to 1 cube? No, it is a false statement. So that means this does not belongs to R. Therefore, it is not symmetric. Yeah. Now for transitive, AB belongs to R, BC belongs to R. That must implies AC belongs to R. So let's find out an example if it is possible. Okay. Now see, if I take tan 3. Let's take two examples. Tan 3 belongs to R and 3 2 belongs to R, right? Why? Because 10 is less than equal to 3 cube. 3 cube is 27. 3 is less than equal to 2 cube because 2 cube is 8. Yes, both are true. But what will you say about 10 2? Is 10 less than equal to 2 cube? No, so this is false. 10 less than equal to 2 cube is false. Therefore, 10 2 does not belong to R. Therefore, it is not transitive. Okay, so that was about question number 5. It's not reflexive, neither symmetric, nor transitive. Clear? So note down question number 5. So now let's move to the next question, that is question number 6. Question number 6. So that the relation R in the set 1 2 3 is given by R equal to 1 2 2 1 is symmetric but neither reflexive nor transitive. Okay. First, let me write down the relation given. R is equal to 1 2 2 1. Now see, here I can see 1 and 2. Okay, so see, is 1 1 belonging to the relation? Here you can clearly see that 1 1 does not belong to R, right? The relation does not belong to the relation, but 1 belongs to the domain, right? So this means that the given relation is not reflexive. Okay, now for the next one, that is symmetric. Okay. Now see what is for symmetric AB belongs to R, that implies BA belongs to R. Here I can see that 1, 2 belongs to R. Okay. And this implies that 2 1 also belongs to R. Right? See, 1 3 is not belonging to R, so we no need to find out that whether 3 1 belong to R. For symmetry, we only need to see that when this first ordered pair belong to R, then its opposite ordered pair must be belonging to R. So this implies that it is symmetric. Clear? Now for transit, I can see 1, 2 belonging to R and 2, 1. These both are same, you can see here. Okay, so 1, 2 belongs to R and 2, 1 belongs to R. So that means 1 and 1 must belong to R for transitive. But in this case, 1, 1 does not belongs to R. Therefore, it is not transitive. Okay, so the given relation is symmetric but neither reflexive nor transitive. Clear? So note down question number 6. Okay, so now let's move to the next, that is question number 7. Question number 7. So that the relation R in a set A of all the books in a library of a college given by R equal to xy such that x and y have the same number of pages in an equivalence relation. Now, what was an equivalence relation? The relation which is symmetric, reflexive, and transitive. Okay, if all three are there, then that relation is called as an equivalence relation. So here we need to prove that the relation R is reflexive, symmetric, and transitive. Okay, so first x y. Now see, for every a, okay, for every a belonging to set a means this is book and this is the same book, so definitely both will have same number of pages, right? So a belongs to R, right? So that means it is reflex. Okay, how it is reflexive? Because A and A, that means both are one and the same book. The same book will have same number of pages. Clear? Now for symmetry, let A B belongs to R. So what does that imply? Number of pages in A equal to number of pages in B. So what does this imply? This means that number of pages, I'm just changing it. Number of pages in B equal to number of pages in A. What does this shows? This shows that A belongs to R, therefore it is symmetric. Okay, therefore it is symmetric. Now for transit, right? See here we have put AB belongs to R, that means BA belongs to R. So it is symmetric. Now for transitive. So for transitive, I will take that AB belongs to R and BC belongs to R. Clear? So here I am writing in short, number of pages in A equal to number of pages in B, and BC belongs to R. That means number of pages in B equal to number of pages in C. Now say number of pages in A equal to number of pages in B, which is equal to number of pages in C. So this implies number of pages in A equal to number of pages in C. So that implies AC belongs to R. That means AB belongs to R, BC belongs to R. That implies AC belongs to R. Therefore, it is transitive. Clear? So just note down question number 7. Here we had proved that this relation is all of the three, that is reflexive, symmetric and transitive. Let's number it 1, 2 and 3. So I can write it down from 1, 2 and 3. It is reflexive, symmetric and transitive. Therefore, it is an equivalence relation. Okay. So now note down question number 7. Okay students, so that's it for today. In our next video lecture, we'll continue with exercise 1.1. We'll continue with question number 8 and try to complete this exercise. Thank you.